over a field F, an inner product on B, an inner product on B is a function from an inner product on B is a function from V cross V to F, V cross V to F that assigns, comma, to every ordered pair, that assigns, comma, to every ordered pair of vectors x and y in B, comma, a scalar in F. Scalar means it's like a constant. Scalar in F, comma, denoted by the inner product of x comma y. This is the symbol for inner product. Inner product of x comma y such that for all x y z belongs to B and alpha belongs to F, the following axioms hold. So take the conditions. First one, axioms hold, HOLD, satisfied. First condition, the inner product of x comma x is greater than 0 if x not equal to 0. Inner product of x comma x is greater than 0 if x is not equal to 0. Second one, inner product of x plus z comma y is equal to inner product of x comma y plus inner product of z comma y. X comma y plus z comma y. Third one, the inner product of alpha x comma y equal to alpha into the inner product of x comma y. Alpha into inner product of x comma y. Fourth condition, inner product of x comma y the whole bar is equal to inner product of y comma x. So these are the four conditions satisfied for it to be an inner product. For elements to be an inner product in a vector space. What is the meaning of this whole bar? Not in this, no. Complex conjugate. This bar denotes the corresponding complex conjugate. Put a command right where this bar denotes the complex conjugate. That bar denotes the complex conjugate. So let's look at what is complex conjugate. No? Yes. If you have number 1 plus 2, what is the conjugate? 1 minus 2. For this one, minus 3, right? Minus 3, plus 2. For I, what is the conjugate of I? Okay, based on this concept, we will be defining our norm also. Norm will be defined using our modulus concept. Okay, everyone is aware of this, right? Anyone the other? Yes? Okay. Take your next one. Make a note. Note. For real numbers, the inner product of xy will be equal to the inner product of yx. For real numbers. Can you tell me why, ma'am? How? What is the fourth condition in our definition? The inner product of xy, the whole bar should be equal to the inner product of yx. If it is real number, what is inner product of xy, the whole bar? xy. Because it is going to be a real number. So only we can say that inner product of xy will be equal to inner product of yx if it is going to be a real number. Okay, for the fourth condition, you can interpret this. Okay, take the next one, definition. Or you can take as properties also. Properties. Properties. If V is an inner product space, comma, then for xy z belongs to V, and scalar alpha belongs to F, the following statements are true. First one, inner product of x comma 0 equal to inner product of 0 comma x is equal to 0. X comma 0 is equal to 0 comma x is equal to 0. Second one, inner product of x comma x is equal to 0 if and only if x equal to 0. If and only if x is equal to 0. Next one, inner product of x comma alpha y is equal to alpha bar into inner product of x comma y. Alpha bar into inner product of x comma y. Actually, in the definition what we are having, inner product of alpha x comma y will be equal to alpha into inner product of x comma y. If alpha is going to be in the first term, if alpha is going to be the second term, what will happen? When you take outside, it becomes as a conjugate, the alpha. If it is in the second term, if you are going to take the scalar outside, it will become as a conjugate. If it is in the first term, you can take alpha as it is. Okay. Next one. This is similar to our second one. Inner product of x comma y plus z is equal to inner product of x comma y plus inner product of x comma z. So there the first term was addition of two vectors. Here the second term is going to be addition of two vectors. Last one. If inner product of xy equal to inner product of xz, if inner product of xy is equal to inner product of xz, for all x belongs to z, for all x belongs to b, then y is equal to z. So we have discussed what is meant by an inner product. Okay, how do you define an inner product of a vector? When a vector is said to be inner product, if it satisfies all these four conditions. So what are the four conditions given? What is the first a vector space, endowed, endowed, endowed with a specific inner product, endowed with a specific inner product is called an inner product space, is called an inner product space. Okay, when we discuss the basis, we define what is our ordered standard basis. Okay, here also we are going to define what is our going to be our standard inner product. Okay, how should we should write the standard inner product for any other space? How to write the standard inner product for a real number system? Okay, two things we are going to discuss. So take down next one. Let x comma y, let x comma y belongs to f power n. X comma y belongs to f power n. What is the meaning of f power n, ma'am? How do you write the elements in f power n? General one. We are dealing with vectors nothing more. If it is f square means how do you write? How do you write elements? Second order elements. Okay, x comma y or a comma b. If it is f cube, third order. So it is fn. So how many elements should be there? Yeah, this is an n order tuple. We are writing it for a general one. So f power n means the elements will be in the form of n ordered tuple. Okay, so right. X comma y belongs to f power n. Then x is equal to a1, a2, etc. an. Y equal to b1, b2, etc. bn. N ordered elements. The inner product x comma y is equal to a1 b1 bar plus a2 b2 bar plus etc. an bn bar. Is called the standard inner product is called the standard inner product of f power n. Is called the standard inner product of f power n. Next one, start with the same sentence. Let x comma y belongs to r power n. X comma y belongs to r power n. We are going to discuss with real system. This f can be real or it can be complex also. Okay, this is for a generalized one. So this particularly we are going to define for the real system. So right, same elements. X is equal to a1, a2, etc. an. Y equal to b1, b2, etc. bn. The nature of the elements only will vary, but the form will be the same. Then the inner product of x comma y is equal to. Can anyone say what is the inner product? No? What is the generalized one? a1 b1 bar plus a2 b2 bar etc. an bn bar. In our second case, we assume it to be a real system. So what happened to b1 bar? a1. What happened to b2 bar? b2, because it is a real system. So the inner product will become a1 b1 plus a2 b2 etc. an bn. This is the inner product, standard inner product, right? Continue. Is called the standard inner product. Is called the standard inner product on R power n. Standard inner product on R power n. So these are some of the definitions and the results you should know. Now we are going to discuss the problems based on our inner product. So any vector space will be said to be inner product space if it satisfies how many conditions? 4. You have to check all the 4 conditions. If all the 4 conditions are satisfied, then we can say our vector space to be an inner product space. Okay. So start with the problems. First one. Let R square have the weighted weighted Euclidean inner product defined by inner product of u comma v equal to 2u1 v1 plus 3u2 v2. This is how we have defined the inner product. 2u1 v1 plus 3u2 v2 and let u equal to 1 comma 1, v equal to 3 comma 2, w equal to 0 comma minus 1. U is 1 1, v is 3 2, w is 0 comma minus 1. Compute the value of inner product of u plus v comma 3w. Compute the inner product of u plus v comma 3w. This is not an 8 mark question, simple 2 more question. Just we are going to find the inner product of this. Okay, how the inner product is defined here? 2u1 v1 plus 3u2 v2. Based on that one, you have to find this answer. How can we find? Can we apply the inner product directly? We have inner product only like x comma y or u comma v. But here it is a sum of 2 terms. So what is the first step you have to do? You have to split them into 2 inner product terms. We have in their properties or in the definition. First you split them into 2 inner products. Then you are going to apply your definition and you are going to get the answer. Okay, so right. Start the solution. Inner product of u plus v inner product of u plus v comma 3w is equal to, how is it written, right? Inner product of u comma 3w plus inner product of v comma 3w. We are going to split them as a sum of 2 inner products. What is the next step you should do, ma? Because we are the definition only for inner product of x comma y, not for any constants. You have to take the constant outside. So how do you take the constant outside? Constant is in the first one or second one? Second one. Second one, if you take it outside, it will become as a conjugate. Just for understanding. Okay, but here what is the number? 3. What is the conjugate of 3? 3. 1 is for complex number, it will vary. This is a real number. So conjugate of 3 is 3 itself. Just for your understanding, as it is the first problem, I am going to write one extra step here. Okay. So when you take 3 from the second term outside, it will become 3 bar. 3 bar into inner product of u V, W, you are going to apply our definition. Okay. So what is the definition for this problem? UV equal to 2 times of U1 V1 plus 3 times of U2 V2. So what are the terms here? U and W. What is our U2? 1 comma 1. What is W? 0 minus 1. So this is U1 U2. This is our V1 V2. Apply the definition. What is the definition now? 2 U1 V1. So the first term is the U1 U2. Second term is the V1 V2. So what is the first term? 3 into U1 V1. So what is U1? 1. What is V1? 0. Plus 2 into plus 3 into U2 V2. What is our U2? 1. What is V2? Minus 1. So 1 into minus 1. Plus 1 let x is equal to next a1 a2 etc. an y equal to b1 b2 etc. bn belongs to f power n, belongs to f power n. Define the inner product. Define the inner product x comma y equal to a1 b1 bar plus a2 b2 bar plus etc. an bn bar. We define like this. Verify f power n is an inner product space. Verify f power n is an inner product space. Okay, ma? Yes. So what you are verifying here? Whether it is an inner product space or not. How many conditions you are verifying? 4. If all those 4 conditions are satisfied, then it is an inner product space. Otherwise, it is not an inner product space. So this is the type of problem that is possible now. Here we are going to discuss generally for f power n. That can be changed anywhere. It may be a real system or it may be given as a complex system also. But the procedure of solving the problem will be the same. Okay. So take down. Start the solution. Let x comma y belongs to f power n. Let x comma y belongs to f power n and alpha belongs to f. Let and alpha belongs to f. So what is the first one condition? Inner product of x comma x is greater than 0 if x not equal to 0. We are going to prove that. Okay, right, first one to prove inner product of x comma x is greater than 0 if x not equal to 0. We have to prove that it is going to be a positive one. So start with the proof. Now we have to define what is inner product of x comma x. So you know how the elements are in x and y and you know the definition. Now instead of y we are going to replace it as x itself. So how will you write the definition? This is the definition of inner product given. Okay, now we will write the inner product of x and with x itself. So how will you write the definition? A1 bar plus A2 bar plus etc. an bar. Because x is 7 elements from A1 to an, so both are x1. So B is going to be replaced by A itself. What is A1 bar? We are multiplying the real as well as the conjugate. How do we rewrite it? How do we rewrite that one? What is called as? That is equal to modulus of A1 square. Modulus of A1 square. The modulus complex system படிக்கும்போது அது படிச்சிருக்கோம். Modulus of A1 square plus modulus of A2 square plus etc. modulus of AN square. The term into the corresponding conjugate. Now this is the answer you are getting. Whether this answer can be negative, this is the answer you got now. Whether it can be negative? No. Why? Modulus. Since it is a modulus, all the terms should be only positive. It cannot be a negative term. So this term should be greater than 0. This term should be greater than 0. எப்போ modulus 0 ஆகும்னா A1 0 இருக்கும். But எல்லா A1 0 இருக்கும். எல்லா A1 0 இருக்க வாய்ப்பு இருக்கா? இல்லை. ஏதாவது ஒன்று ரெண்டு sometimes can be 0. But others will be existing. So அதோட modulus இருக்கும்போது first condition is satisfied. Okay, so take the next one. What is the second one to prove? Inner product of x plus z, comma y should be equal to inner product of x comma y plus inner product of z comma y. Same procedure, we are going to just rewrite and we are going to prove that LHS is equal to the RHS. Okay, right, second one. To prove inner product of x plus z comma y is equal to inner product of x comma y plus inner product of z comma y. This is what you are supposed to prove. So we are going to start with our LHS now. What is the first term in LHS? X plus z. So first find what is x plus z. Or before that, we write one line. Let z belongs to f power n. Because in first step we define only x power. Tell me how you write z now. C1, C2, etc. C. X is A1, A2, etc. AN. Y is B1, B2, etc. BN. So z can be written as C1, C2, etc. C. Now tell me what is x plus z? What is x plus z? How the elements will be in x plus z? A1 plus C1, comma A2 plus C2, etc. AN plus C. Ordinary vector addition. We are adding two vectors, x plus z. Now apply the inner product definition. Start with the LHS. Inner product of x plus z comma y is equal to. What is the definition given now? See the definition. Definition what is it? Write it down. A1 B1 bar plus A2 B2 bar etc. What is the pattern? The first term element should be the same. Only the second term element should be changed as conjugate. Okay. Here what is the first term? X plus z. So those elements should be the same. Only the element from y should be changed as a conjugate. So how do you write this one according to definition? A1 plus C1 into B1 bar. Can you understand now? Definition is A1, B1 bar. A1 is the element in the first term, B1 is the element in the second term. Here what is the first term? X plus z. So we must consider the elements from x plus z. So that term will remain the same. So the second term element should be written as a conjugate. Plus A2 plus C2 into B2 bar. Plus etc. AN CN into BN. BN. Now can you prove your RHS or not? Now prove it. What is the right hand side you have to prove? Inner product of x comma y and z comma y. X comma y means what are the elements should be combining? A and B. For z comma y, C and D. Whether it is possible or not? And it is ordinary vector addition. So you can split and write this one to be A1 B1 bar plus A2 B2 bar plus etc. AN BN bar plus C1 B1 bar plus C2 B2 bar plus etc. CN BN bar. Just ordinary vector addition. So you can split and write like this. So according to definition, what is the first one now? Inner product of x comma y. Second one, inner product of z comma. Whether it is the RHS or not. So it's proved. Easy or not? What is the third one? Everyone completed this one? Still anyone writing? Shall I continue? Completed. What is the third one you have to prove? Inner product of alpha x comma y should be equal to alpha into inner product of x comma y. So right, third one to prove inner product of alpha x comma y is equal to alpha into inner product of x comma y. This is what you are supposed to prove. So I will start with LHS. Inner product of alpha x comma y is equal to, what is x now? A1, etc. So what will be alpha x? Alpha A1, alpha A, etc. alpha A. Okay. Applying the definition. What is the definition? Inner product of xy equal to A1 B1 bar, A2 B2 bar, etc. Instead of A1, what you are going to write here? Alpha A1. Good, right. Alpha A1 into B1 bar plus alpha A2 into B2 bar plus etc. Alpha AN into BN bar. So this is only vector addition. So what you can do with alpha? It can be taken as a common term outside because this is only ordinary addition. So alpha. If you have taken alpha outside, what is the remaining? A1 B1 bar plus A2 B2 bar, etc. What is that one? Alpha inner product of x comma y. That is what you are supposed to do. Now we are with the last result. Should we discuss the last one now? So what is the last one you have to prove? Equal to whole bar is equal to inner product of y comma x. Okay. Already you know what is the inner product of x comma y. Okay. You write that part and apply the conjugate for the inner product of x comma y. Okay. So start. Inner product of x comma y equal to inner product of x comma y equal to A1 B1 bar plus A2 B2 bar plus etc. AN BN bar. We are writing the definition. But what is that we need? xy whole bar. So apply the conjugate complex conjugate on both sides. So what happened? Inner product of xy whole bar is equal to A1 B1 bar plus A2 B2 bar plus etc. AN BN bar, the whole bar. We are going to apply the complex conjugate for the entire field. So now apply the conjugate for each term. A1, if you apply the conjugate, what will become? A1 bar. This is B1 bar. Again the conjugate will become A2. The conjugate of the conjugate is the original itself. Okay. So what happened to the next one? A2 bar, B2. Apply the conjugate for each term separately. Plus etc. AN bar. Can you identify what is this one? Compare with definition. Inner product of y comma x. Can you identify? Put it and rewrite it one step. We got to rewrite B1 A1 bar, B2 A2 bar, plus etc. BN AN bar. So according to our definition, the second term should be the bar. The first one is the same number itself. So Whether all the four conditions are true. So what is the conclusion you can give? Hence, F power n is an inner product space. You are supposed to check that one. Conclusion. Hence, F power n is an inner product space. Norm. Okay, norm of a vector or norm of an inner product space. Right, next topic. Norms. N-O-R-M-S. Norms. N-O-R-M-S. Norms. N-O-R-M-S. Norms. We're gonna continue definition. Let B be an inner product space. Let B be an inner product space and X belongs to B. Let B be an inner product space and X belongs to B. Then norm or length of X is denoted by this symbol double. Norm of X and is defined by square root of inner product of X comma y. Inner product of X comma, sorry, not y, no. We are defining for X. So inner product of X comma X. So what is norm? What is the other one I told you? Length. Okay, length of the given vector. To identify the length of given vector, that is called as the norm here. So how we define norm of X? Square root of inner product of X comma X. So only first topic we discussed what is our inner product. Okay, so what is norm of X? Square root of inner product of X comma X. It is nothing but like our distance in our one dimensional field. One dimensional, two dimensional, define the distance node. So in vector space it is called as the norm. Okay, so right. Start with the sums, problems. First one. Any doubt now? Right. Find the norm of the following vectors. Norm of the following vectors. In V3 of R with standard inner product. First subdivision, we have defined the norm of the vector 1, 2, 3. The vector is given as 1, 2, 3. So what are you supposed to find now? The norm. We have defined what is the norm of this vector. How we define the norm? Square root of inner product of X comma X. That inner product definition is not given here. But instead of that, what I mentioned, make use of the that is the space. Apart from that one, what is the identification given for inner product? For previous problem la pathina inner product in the formula la we define pannanga in the statement la it is given as standard inner product. The previous problem la they defined inner product of X comma y equal to a1 b1 bar etc. Whether the definition is given here, not given. Instead of that, what I have told you, make use of the standard inner product. Already gave you two inner products. One is for a complex system and the other one is for a real system. You have to take the help of the standard definition and then you have to find what is the norm of this. Can you understand now? Tell me now what space you are. V3 of R. V3 means it is a 3-ordered triple. Okay. R means what it indicates? So what is the question here? Let us find the norm of 1 over 2. Okay, let us say this will be x. We are supposed to find what is norm of x. To identify the norm, we need what is the inner product. Okay, you should know how to define inner product. Then one you can simplify that and you can get this value. Okay, whether the definition is given in the statement. Statement define பண்ணிருக்காங்க பண்ணு. வேற ஒரு theme கொடுத்திருக்காங்க. What is the theme given? Standard inner product. When I define the inner product, I gave you two more definition. What is the standard inner product for complex system and what is the standard inner product for real system? Here, what is the system given? In a degree of R is given. So we are going to take that standard inner product and we are going to solve this. Is it clear now? Yes. So start the solution. Inner product of x comma y is equal to a1 b1 plus a2 b2 plus etc. an bn yes the standard inner product of V3 of R. Standard inner product of V3 of R. Right? Therefore, norm of x square is equal to square root of inner product of x comma x. Norm of x square is equal to square root of inner product of x comma x. So to substitute in this one, first you have to find what is inner product of x comma x. Find that one, inner product of x comma x. This is the definition, this is for x comma y. Okay, what will the answer for x and x? X and x a1. So what is a1 in a1? a1 square plus a2 square plus etc. an square. So this is equal to a1 square plus a2 square plus etc. an square. This is the definition of inner product of x comma x. But what is the elements given here for x? 1, 2, 3. So what will the answer? 1 square plus 2 square plus 3 square. Only 3 elements.
Norm of x the whole square of
Norm of x, not square root. Norm of x equal to square root. Now write what is the answer? Tell me what is the answer? 4. So what is inner product of x comma x? 14. Find norm of x. Therefore, norm of x is equal to square root of 14. Square root of inner product of x comma x. This is the distance. Okay. How many mark question was this one? 2. Second subdivision is the same question. Second subdivision. Find inner product of major question வந்து என்னது? Find the norm. You have to find the norm for this inner product. So 4x plus 5. 4x plus 5. Our overall title is find the norm for each of the following categories. The second category is inner product of 4x plus 5 where x is equal to 1 minus 1 0, y equal to 1 2 3. Y equal to 1 2 3. Y equal to 1 2 3. Same procedure ma. Here what is the element given? 4x plus 5. First you identify what is that one. Find what is 4x plus 5 1. You need this one now. First you are finding what is 4x plus 5. Tell me what is 4x? 4 minus 4 0. What is 5 1? Now add 4x plus 5 1. Add how much? 9 let u equal to 4x plus 5y. So norm of u square is equal to, then we how we find now? What is norm of u square? Square root of inner product of 2 comma 1. Already the first subdivision we have defined. What is inner product of x comma x? Definition ma? a1 square plus a2 square. Square root போடாம இருக்கு அவ்வளவுதான். What is norm of, sorry, inner product of x and x? a1 square, a2 square, x. Apna norm of x comma x for this problem, what is the definition? Each element should be square. Adha namakku theriயும். Okay, what is the answer for 4x plus 5y? 9x, 6 and 15. Okay, so what is the norm answer? 9x square plus 6 square plus 15 square. Can you understand now? Okay, so what is norm of x? Norm of x is square root of inner product of x comma x. Here instead of x we are having it as u. So square root of inner product of u comma u. Okay, by instead of x we are having it as u. What is the pattern of inner product? a1 square plus a2 square plus etc. an square. Okay, so நம்ம என்ன பண்ணோம்? x ஓட ஒவ்வொரு எலிமெண்ட் எடுத்து ஸ்கொயர். Okay, x க்கு பதிலா நமக்கு என்ன இருக்கு? u. So u ஓட எலிமெண்ட்ஸ் என்ன இருக்கு? 9 6. அப்ப நம்ம என்ன பண்ணனும்? u ஓட ஒவ்வொரு எலிமெண்ட்ஸ் எடுத்து என்ன பண்ணனும்? ஸ்கொயர். So this is equal to square root of 9x square plus 6 square plus 15 square. Find what is the answer? 342. Any doubt ma? This is a simple 2 mark questions to understand how to find a norm. Shall we continue? Any doubts? Any doubts, please discuss with me, not among yourself. Any doubts? How to identify the norm? Take our next problem. Next one. Find the norm if you want me to continue, you should remain in silence. கீழே யாராவது நீ கிளாஸ் எடுத்துங்களா? இவங்க கம்மியான மொபைல் வச்சுட்டியா? அது என்ன கீழே வந்து கேட்காம இதை பண்ணிட்டு படுக்க வந்து அப்புறம் கீழே ஏதாவது தனியாக படம் ஒரு தடவை வச்சு அப்புறம் அதுதானே மார்னிங் வந்து மொபைலை கனெக்ட் பண்ணுவேன். திருப்பி எழுதாமல் நீ அதே வேலை தான் பண்ண முடியாது. So right, next one. Find the norm in F cube. Find the norm in F cube, comma, x is equal to 1 plus I, comma, 2, comma, I. Complex system. 1 plus I, comma, 2, comma, I. Y equal to 3I, comma, 2 plus 3I, comma, 4. Find norm of x plus y and inner product of x comma y. Norm of x plus y and inner product of x comma y. Okay. What are the two things you will find? Norm as well as the inner product. Okay. Shall we find the inner product first or norm? Inner product of x comma y. So how you define? Whether it's defined in a statement, any definition is given or not given? Not given. Not given means what you have to do? Standard inner product. Complex system or real system? Complex. So what is the definition? A1 B1 bar plus A2 B2 bar plus etc. AN BN bar. So start the solution. Standard inner product. The standard inner product is given by the standard inner product is given by inner product of x comma y equal to a1 b1 bar plus a2 b2 bar plus etc. an bn bar. Okay, what is explained by given here? 1 plus I 2i 3i 2 plus 3i 4. So this is a1 a2 a3, this is b1 b2 a3. So substitute in your definition. What is the first one? A1. So 1 plus I. What is b1? 3i. So 3i the whole plus. What is a2? 2. What is b2 for us? 2 plus 3. So 2 plus 3i the whole plus a3 is I and b3 is 4. So 4. Identify the conjugate for each. 1 plus I. What is conjugate of 3i? Minus 3. Actually conjugate of 3 is 3 itself. What is conjugate of I? Minus I. So only we get as minus 3i plus 2 into. Conjugate of 2 plus 3i? 2 minus 3 plus I into. Conjugate of 4? 4. Real number remains the same. Simplify and tell me the answer. Combine all the constants and combine all the imaginary terms. So if you multiply minus 3i. What is I into I? What is I square? Minus 1. I square is minus 1. So minus into minus will become plus. So plus 3. Plus. Multiply into inside. 4 minus inside. Plus 4. Add 7 minus 5. Is that clear everyone? Yes? Any doubt? So now you have completed what is inner product of x comma y. What is the next one you have to find? Norm of x plus y. First you add x plus y and find what is the answer for that one. For that one you have to find what is here norm. Okay, add x plus y. Add x plus y. X plus y equal to. Add the corresponding terms. 1 plus I plus 3i. 1 plus 4. 2 plus 3i. 4 plus 3i. I plus 4. This is our x plus 1. Okay. Now what is the next one you have to find? Now what is the norm definition? Square root of inner product of x comma x. Here instead of x we are having it as x plus 1. Right? Inner product of norm of x is equal to square root of inner product of x comma x. X comma x. So the previous problem போடும்போது என்ன ஆகும்? Already identify the square root. என்ன பண்ணுங்க inner product ஓட previous problem recall previous problem. எப்படி நான் கண்டுபிடிச்சேன்? அந்த inner product over எடுத்து என்ன பண்ண? Square பண்ணி add பண்ண. Because it is a real system. Just as it is we square and add. But here we are in a complex system. அப்ப என்ன பண்ணலாம்? அங்க எதனால இந்த ஸ்கொயர் சொல்றோம்? a1 ஸ்கொயர் எதனால வந்தது? a1 into a1 தான். அது real system ஆனதுனால it becomes as a1 square. but நம்ம இங்க complex conjugate அப்ப நம்ம எப்படி எழுதணும்? a1 into a1 bar plus b1 into b1 bar plus c1 into c1 bar. புரியுதா? என்ன டிஃபரன்ஸ் இருக்கு? அங்க real system ஆனதுனால எல்லா நம்பர்ஸையும் டைரக்டா ஸ்கொயர் பண்ணுவோம். but இங்க என்ன வருது complex. அதனால that element into the conjugate. Okay, அதுதான் உங்களோட அந்த ஸ்கொயர் ரூட்ல எழுத வேண்டிய இன்னர் ப்ராப்பர்ட்டி. Okay, so this is equal to square root of what is the first element you are having? 1 plus 4i. So 1 plus 4i into 1 plus 4i the whole conjugate. Okay, the real system andanaala direct square right. Okay, plus what is the second one? 4 plus 3i. So 4 plus 3i into 4 plus 3i the whole plus last one 4 plus 5 into 4 plus 5 the whole one. Tell me how will you simplify? Just for convenience, norm x square kodukkalama so that we can remove that square root. Last square root. So what is 1 plus 4i the whole bar? 1 minus 4i. So 1 plus 4i into 1 minus 4i plus 4 plus 3i into 4 minus 3i plus last one 4 plus I into 4 minus I, the corresponding conjugate. How will you simplify this one, ma'am? When you multiply what is the easiest way? A plus B into A minus B. What is the formula? A square plus B square, right? A square minus B square. Okay, so this is equal to, this is our A2, this is our B2. So what you will get? 1 square plus 4i square. Okay, what is the next term? 4 square minus 3i the whole square. Yes? 4 square minus I square. A plus B into A minus B is A square minus B square. We are using that formula. Now tell me what happened to this 4x square? 16 I square. What is I square? Minus 1. So minus into become plus. So 1 plus 16 plus 16. What happened to this one? Plus 9. Because again I square is minus 1, so that will become plus 9. Plus next term 4 square is again 16. I square is minus 1, so plus 1. Okay. Just one more point I want to share now. I have told you all these things elaborately. Instead of that one, if you are thorough with complex system, you can write that as last step limit. Okay, well, because what I told you already, modulus of A plus IB will be equal to square root of A square plus B square. What is the meaning of modulus of A plus IB? It is nothing but A plus IB into A minus I. That is modulus. Okay, this is for an understanding. நல்லா தரவா தெரியும் என்ன பண்றாங்க இந்த ஸ்டெப் எடுத்துல here itself you can derive this to be square root of 1 square plus 4 square plus 4 square plus 3 square plus 4 square plus 1 square because we know already this square. So what is modulus of A plus IB? Square root of A square plus B square. Okay, so the square root என்ன பண்ணலாம்? The square of the real number plus the square of the imaginary one. Directly you can write that answer also if you are thorough. Otherwise, going to this elaborate step and get the answer. Anyway, both the answers you are going to get the same. Any doubt now? Any doubt with now? How to discuss a real number system and complex system?